The death of software engineering and the future of AI engineering. If you go on LinkedIn, something feels off. You see layoffs all the time. You see companies reducing their staff 10, 20, 25%. And also what you're seeing as well, you're seeing a lot of AI demos everywhere. Basically, people say, hey, look what I did. Just putting a single prompt and they have a whole app created, right? And you ask yourself, is it worth learning to code? What I would say is the old way of software engineering is dying, but is not dying as you think. What's actually dying, first of all, I would like to say the software engineer career that lives, it's the big team scale model. That's what's dying. So basically having really, really big teams of like 500 software engineers, because cheap money has ended. Basically what was done in the past is that you would hire, like tech companies would hire a lot of engineers as long as they pass the coding interview and they're able to answer those types of questions and they're skilled enough. They would have, the only metric they had is pretty much growth, right? Now in more recent years, profit is more of a pressure. So now they're getting a little more scrutinous about what is actually needed here. And do we really need 500 engineers to solve this problem? Can we do it with 100 engineers, for example? And that's where we have headcount that gets cut, right? Now, especially with the rise of AI amplifies engineers, right? So basically, just because you could type code, that almost like devalues it, because if you are able to do the same thing, but you have AI write out the code for you, as opposed to you typing it out, there's no real value to that. What's more valuable is the fact that you know how to architect it, and you know how to actually drive and link a business value towards that. So that also goes down to the fact that, okay, well, could we have a couple of skilled engineers who know how to use AI to fill in the gaps and get the same job done? What I'm seeing now, there are three types of engineers that's going to be present in 2026. The first one is what I like to call a prompt engineer. So basically they're prompt jockeys. What they pretty much do is just copy and paste prompts into something like ChatGPT, and they get some type of code and then you see it work. But so they just copy and paste. There's no debugging, no depth to it at all. So it's fine for quick little things, but then if something goes wrong, then they can't fix it because they don't actually understand what's happening. Now, the thing is, you might think that is valuable, which is good to get something done quickly, but if you could do this and anybody else could do this, that doesn't make you actually a skilled worker or a valuable worker. That just makes you a hobbyist, right? Being able to understand what's happening behind it and direct it, that's what actually makes you skilled. Which then goes to the second one, which is, I would say, is the purist. So it's the opposite of a prompt jockey. What they do is they completely reject AI tools because they feel that they've spent years honing their skills and they feel very proud of that, which they should be proud of that, right? Now, the thing is about them is that they reject AI tools completely. They feel that they're a purist. They have to type every single line of code, which means it's going to take, it's a lot longer for them to ship. It's slower for shipping. And over time, they're going to lose leverage because you could have someone else who's actually knows how to code itself, but actually using AI to help fill in the gap, that they don't have to type it out. They just write it out and they guide it, which means that they could deliver a lot faster than the purists will. Now, over time, when companies are doing layoffs and they, again, like I mentioned, now they have to account for profit, and they're checking out and they see two engineers, one delivers faster than the other because one is using AI to fill in the coding, the other one's typing. Do you think a company's going to care about your own like moral or your own obligation or your purist obligation of actually writing code to it? No, that is your own goal towards that. And at the end of the day, you have to be able to deliver. And if AI is able to do that to help you fill out the code a lot faster, it's going to be a lot easier for you to basically show your worth to the company. Now, the third one, which I touched upon, is the AI engineer. So basically, it's the purist they have the skill of a purist. They can actually write the code. They have the real fundamentals. And if they had to, they actually could write the code from scratch. But They also know how to prompt AI or use AI to leverage and fill in the gaps for them. So they basically use their fundamentals plus the AI systems in production to actually bring business value to this, right? And this is where the value is to companies, because you actually understand what's happening and you actually use AI to your advantage to speed up. It's a multiplier in this case. It's not replacing you, it's actually a multiplier. And this was very similar in the past when accountants were used to do all their calculations by hand, and then spreadsheets came around. I think around the time that was like Lotus Works or something like that, but probably most people know like Excel. So when Excel came around, people were, a lot of the accountants or the people who were doing financial analysis felt a little threatened because this new tool comes in, and what we were doing by hand, writing out all the formulas by hand, now you could do this super quickly on Excel. Now, what happened though is that just because you know how to use Excel doesn't mean you're a financial analyst, right? It's the same thing with AI engineering. Just because you know how to prompt doesn't mean you actually know what's happening. You still need to know how to code and the fundamentals and what's actually happening to be useful. So still, at the end of the day, the people who actually know the fundamentals, who are actually skilled, are the ones who are actually leveraging AI to make them a lot more efficient. The AI engineering opportunity. Right now, when people think of AI or AI jobs, immediately they think of I would describe as a PhD researcher, where they would have to learn all the mathematics, what is back testing, forward propagation, back propagation, learn calculus, what's a gradient, and then statistical and linear algebra. Now, the thing is, that's very important, but that's not the only job. In fact, if you're trying to be an AI engineer, you would leave that to the researchers, right? The thing is, researchers, they build the models, but they don't actually release code to be done in production. That's what an AI engineer would do. They actually take the models that these PhD researchers created and actually apply it to a business need and actually implement it and release it. And this is where the production implementation is super important around these models, basically taking that and mapping it to a real business need. That's what an AI engineer actually does, right? So you are able to map that and figure out what is the business value. What are the wins for it? Accuracy alone is useless in the terms of AI engineering. Now, if you're becoming a PhD researcher, then you're trying to beat the latest paper, the state of the art, and beat the metrics from that to improve the models. But as an AI engineer, you're trying to solve a business need, and those metrics in that context doesn't really matter. So it's a rare intersection to have AI engineering plus, having AI as a product outcome, right? So the thing is, like, you have to map, but basically what that means, you have to map the model and figure out what is the business need and what is the outcome that's ideal for the customer, because they don't know what's happening under the hood. They just know, is it solving my problem or not? And to give an example, my first job is when I started as an AI engineer, I worked basically writing algorithms to predict the stock market and for a company, and I would give these algorithms to a portfolio manager. So how that worked is I would get the latest papers that were released during the last two weeks, and we had to read them and then take that, interpret that, and implement them into an algorithm, and then back test it against the market and see if they worked. And if they did work, then I would give it to the portfolio manager. They would test it and put in their portfolio mix to see how well it would do, right? Now, they didn't care at all about the accuracy or what is the best state-of-the-art metrics out there. At the end of the day, is it actually making the client money? And which is the only reason people care. They don't care how you do it. The clients don't care how you do it. Are you actually making money out of it? So that's in a case where you have business value there, right? As a PhD researcher, their goal is not to look at that business value. Their goal is to optimize the model and make it more efficient. But as an AI engineer, your goal is actually to optimize for the business value, whatever that business value may be. How to make the transition? If you're a current traditional software engineer, or you want to get into software engineering, you're starting from scratch. In fact, I had someone this weekend I met that is finishing their boot camp of software engineering and was asking me, is it even worth going to university? Because he was contemplating that, but now he's seeing what's happening in the world, especially with AI. So my suggestion here is learn just in time, not like basically just in case, meaning that you learn what you need to know, right? Then build first, solve one problem at a time. Your skills will compound, right? Your best work is your finished work, right? So build just in time, learn what you need to know, learn just in time, I mean. So the other thing is your domain is your edge, right? So if you are in a specific domain and you know your domain very well, if you're able to apply AI to the solution for it, and apply AIs to have solutions for different problems you know your domain faces, you're going to have the advantage because you know exactly what success looks like, what the right answer is supposed to be. Even if I know AI engineering, if I don't know your domain, I don't know what the meaning of certain things are. I don't know what success means. I don't know the significance of certain things, right? Whereas you in your own domain would know all that stuff, and that will make you, it's basically your superpowers and put you heads and shoulders above everyone else, right? And the other thing is AI plus context beats pure theory, right? Again, this goes back to having like a business case where business value, where you see this is solving this type of problem that people are having and that they care about, then it just so happens to be using AI. That's what they would care about, not the fact that it's using AI. The other thing is you want to make, this goes back to the first thing here about the domain expertise here, you want to ship real solutions. What are real problems that people are facing, and actually show how you solve that. And you want to document the value, like why does it actually matter? And the main thing about this is to translate to stakeholders. This is what I mentioned down here, where you say be able to explain AI, or basically the stakes, to non-AI stakeholders. Like your job is to take that, translate that. They don't really care about all the complicated things you did at the end of it. They really care about what does it mean for them? What does it mean as a bottom line? They want you to interpret that data and explain it to them so they can understand. And this is a big skill set that you should learn how to do no matter what domain you're in. To be able to explain it to stakeholders of people who are decision makers, to inform them in a manner that they can understand. That's where having visualizations or give comparison of what it means if you do it this way, what it means if you don't do it this way, and give your recommendation. The old software engineering model, that has ended. It's more now the AI engineering that is on the rise right now, right? You have to choose your path. Right now, if you are a prompt jockey, that's fine as long as you know you have to bridge the gap. If you're currently a purist, you have to be aware that you might have a threat at the moment where other people who know the fundamentals but are also using AI to expedite or speed up their workflow, they're more of a threat to you, because when it comes down to cutting headcount, because profit is going to be one of the metrics that people are checking and want to see, can we still maintain this? Can we lower our costs but still have our output? And they're going to look at two people, and if one is able to produce very good work, two people are able to do very good work, but one does it faster than the other because one is using AI, you're at threat. You're at risk right here. And then what you ideally want to be is the AI engineer, where you are skilled as a purist, meaning like you know the fundamentals. If you had to code everything from scratch and design it, you can. But you're like a prompt jockey in the sense that you know how to prompt and use AI to like fill in the code for you, or fill in the boilerplate, where you think of more of the high level and figure out the architecture, the data structures, the algorithms, and whatnot, right? Think of it like this way. If a purist might be like a mathematician that insists that they want to write everything by hand on paper, whereas someone else, like an AI engineer, would be like a person that they're able to write everything by hand, but they'll use a calculator to do it. And so what I would suggest right now is this AI opportunity happened so quickly. Even this time last year, software engineering was definitely a big thing, but now especially with the concept of vibe coding, which is more, I would say, like prompt jockey right here. Just in 2025, mid 2025, that it grows up a lot. Here's an opportunity. So you would have to, let's say, move now to learn how to do these two things. Learn how the fundamentals of coding and the data structures, algorithms, and whatnot, and learn how to use AI prompt engineering to help speed that up to become an AI engineer. You have to move on this fast because the window will close. You don't want to be left behind while everyone moves forward, right? And if you want more tips and tricks, you could watch our next video.